Greetings, my dear students. So we are going to see the last topic of our engineering graphics paper, which is how to convert uh, the pictorial view into a orthographic view, or in the sense you are given an isometric view like this, a solid, and you are given three arrow marks, or you are required to draw the front view, the top view, and the side view. Okay, it's optional. Either in most of the cases you are required to draw only the front view and the top view. The front view is indicated by a F and an arrow mark sign. So in this direction it is supposed to be the front view, and here it will be indicated by a T, and basically you'll be given an isometric view, and you have to draw the three views or two views of the solid. So how do you go about it? That's what we are going to see. So when you look from here, what do you see in the 2D figure? So you see the 2D outline of this figure. Okay, so the best way to tackle this is, imagine that if you are lighting a torch from here, in which all surfaces the light will fall. Okay, I'm going to shade that surface. Okay, so this is a surface where the light falls. Okay, there is a cavity here, right? So if it is exactly perpendicular in this direction, the light will only fall in this shaded surface. So that's exactly what you need to draw. So the answer is, you make a rough sketch here. You have a 50. I'm going to draw this line 50. This is how much? 35. See, 35. So 35. Then what? 20. This distance is 25. 25. And don't know this distance, so I'm going to start from here. So 50 is actually this. That's 50. This is 75 minus 25 plus 10 plus 10, 30. This 15, 10. Then again 15 downwards, 10 here, 5 upwards. How much is this distance? 25, right? 25. Then you have 10 upwards. So after 10, you're going to join this point and this point, which is like this. Okay, I haven't drawn it in a scale fashion, that's why it is not matching this figure. But basically what you need to do is, why is this a distorted figure? This 25 and this 30 doesn't match, this 50 and this 35 doesn't match. So that's why it's appearing to be a slightly different figure than what you see here. So basically, why I have done this, because if I draw a rough sketch like this will be more handy to make a fair sketch. Okay, so now let's complete the top view. So in the top view, the same approach is what we are going to see. So we are going to look in this. We are going to look in this direction. In this direction, you look at this figure. Make some space for the drawing. Okay, in this direction, when you look at the figure, I'm going to shade the portion. So I'm going to rub off the first portion to give you a clear understanding. I'm going to shade the portion which is seen in the top view. Okay, I'm going to see this portion, or you can say when you light a torch from the top, light is going to fall in this surface. It's not going to fall in this surface. It's only going to fall in all the horizontal surface. See, so that's the way you understand things. You identify all the horizontal surface and the slanting surface also. Okay, when you look from here, this direction, light is sure to fall on this slanting surface also. So you look from the top, you see this rectangle as a smaller one, as a slightly shrunk one. Okay, so you won't see this one because it's a vertical surface. So when you look from the top, these are the three surfaces that you see essentially. So we are going to start with this one. So this is 35. I'm going to draw 35. This is 60. 60. Okay, this is again 35. 35, right? This is 15. 15. Inside the distance is 20, right? 20. Up you go. The same thing. This is 15, because if you calculate 30 plus 15, 45, 45, 60 minus 45 is 15. So this is also 15. This is also 20. Okay. And this is 30. It's given. So that is the surface, and from here this distance is 25. 25. Okay. And we are going to make this rectangle, this line also. It's 25. And what is this distance? How do you calculate this distance? It's not, we don't need to calculate the slanting distance, we actually need to calculate this distance. Okay, now what is that distance? The whole distance is 75 minus 25 minus 35, right? Correct? 35, 40, 60, 15. So this happens to be 15. 75 minus 25 minus 35. Okay, so you have to look very closely to find out the dimensions. So that is 15. Again down, complete that. So that's your answer. Okay, the top view. The side view, again gonna rub off this thing and look from this direction. So when you look in this direction, what do you see? I'm going to shade this surface, obviously the slanting surface. You can see when you look in this direction, the light will fall in this direction, and now the light, apart from this, the light will fall in all the vertical surface. Okay, in all the vertical surface, because your view is in this direction. So light won't fall on this surface, this horizontal surface. So all the vertical surfaces are like that. So you'll see this rectangle, this rectangle, this one, and this one. You won't see these rectangles. Okay, so when you draw the figure, I guess you can see this. I'm going to make it very small. The whole of 60 mm from here to here. I'm going to draw that line. And inside that 60 mm outline, this rectangle, 20, 15. Okay, 20, 15. Here also you have the same kind of rectangle, a 20, 15 rectangle. Okay, just complete that, because you can see this edge also, so you should complete that. And this edge and this edge are on the same surface, so from here you can take the rectangle. What would be the height of this rectangle? We need this height. How do you calculate that? So 50 minus 20 will give you 30. From here to here is 30. 30 minus 15 is 15, right? Guess you can see this. Okay, 50 minus 20, 30. So from here to here it's 30. 50 minus 20 is 30. 30. From 30, what you have to subtract is, from down you have a 5, and here you have a 10. 15. 30 minus 15, 15. So from here to here it's 15. So that's what you have drawn here, 15. Then the rest of this 10. Now let's check whether our answer is correct or not. 20 plus 15, 35 plus 10, 45. So altogether it's 45, but here it's 50. So we have missed something. Let's see. This is 20. Okay, 20. This is calculated by 15. Okay. All right. 15 and this 10. We have missed this one. So when you look from here, beneath this line, you have this small pocket. See? Okay, you can see this rectangle. and below that, underneath this rectangle, there is a small rectangle which is of 5 mm. So that 5 mm comes here, 5. Okay, 20 plus 15 plus 10, 15, 15, 30, 20, 50. So now it's matching. Okay, so you have to check. This is a very good check. You add up the individual dimensions and it makes up the whole dimension. Then your drawing is perfect. Okay, you have to check that. So this is a complete drawing. Okay, just showing you the front view which we have drawn here. Okay, this one, front view, the top view, and the side view. Okay, so what I've done here, I just started with the top view first, then I make sure that all these projectors are on the same line. Okay, okay, draw the XY line, start with the top view. You can just start with the top view as we have done here, rough sketch here, a 60, 75 rectangle, and inside that can make this 15, 25, 28, this line of 15, 15. Again, it's not a big deal. Okay, you can make the top view drawing and you can extend these lines, and 50, 35, 25 can make this drawing. That's not a big deal. The point you have to notice that uh, when you draw a side view, when you look object in this direction, whatever that you see is drawn at the left side. Okay, so this is your front view, this is the right side, and this is your left side. Okay, this is your front view, right side and left side of the object. So when you look an object from the right side, the image obtained is drawn the left side, whereas if you look at object on the left side, from the left side, the image obtained is drawn the right side. So that is the essence of first angle projection. So that's why I have drawn the image in the left side. So this indicates, from when I look at this image, I'll get an idea. Okay, this is what it looks like when you look from in this direction. In this direction, if you look, whatever that you see in this direction is projected here. Okay, whatever that you see in this direction is projected here. Whatever that you see in this direction is projected here. All right. Now there is one more thing I just want to point out is the effect of hidden edges. So what you've drawn here is correct but not perfect. If you want to perfectly make the drawing, when you look from here, say let's say when you're looking from the top, you see these hidden edges. Okay, or else you can see a cavity here, right? The beneath the bottom side you can see a cavity, and because of this cavity long edges go like this. Okay, when you look from here you see a pocket here, and the edges of the pocket goes all along. So when you look from the top, you won't see this edges because of the surface here, but you have to show this edge as a hidden one. So after making the drawing, you just identify that, and this is where when you look from here, this is the hidden edge that you see in the top view. So it goes all the way along. Okay, so that's what I'm doing, goes all the way. And this one also, no exception. Okay, now in machine drawing, if you have a pin or a shaft going in between, you won't make that drawing. But just this is a secondary thing actually. You don't need to pay too much attention on this. You don't need to worry if you don't understand this. What I'm saying is, when you look from here, you can see this edge, you mark this edge, right? Similarly, because of this surface, you can't see this edge, which means that is a hidden edge. A hidden edge should be marked in this fashion. Okay, and you can see a hidden edge here also. See, and that goes all the way through the. So all these hidden edges should be shown as a dashed line. The top view. In the front view, if you see, there is a hidden edge here. There is a hidden edge here. See, so that can be projected from here. but you have to pay attention that is only seen in this up to this point only. So from 20 mm to this point you can see this edge like this. See, up to this point. Right. So when you look at this figure, okay, you can make it out. Oh, the front view looks like this, but there is a pocket over there, and there is a edge going like that. And how do you find out that edge? When you look at the top view, okay, this is why you have edge there. That's how you make it out. Okay. And if you see these edges, you can make it out. Okay, the top view, there are three. There is some edges lying beneath the solid. Okay, so that is what this indicates. And how about the side view? When you look from the side, these are the pockets, but this 15 is actually matching with this 15, right? See, because of that coincides. I guess you can see this 15, this edge. When you look from this side, this edge and this edge coincides, and because of that edge, the hidden edge and the solid edge coincides. Because of that, you don't need to draw this edge, and this is also seen. We have also drawn that also. So in the side view, the probable edge should be this one, and that is taken care of. Other than that, there is no hidden edges in the side view. So this completes your drawing. Alright, so what I'm going to do is I'm going to make the same drawing in a CAD. Using an AutoCAD software, I'm going to make the same drawing. The top view, the front view, side view is optional actually, you don't need to draw it. So my intention is to get you familiarized with some of the tools that you use in AutoCAD, some of the commands that you use in the AutoCAD. Simple commands to draw the line at an angle, draw a straight line, a perpendicular line. How do you make these drawings in a easy manner using AutoCAD software? That is my intention. Okay, we'll see that next.